This is a type of problem where we're still using Hess's law, but we're using the second method. So we're not given a series of equations, so I know that I'm not looking to find a net reaction. I'm just given one equation, and they want me to solve for delta H. As long as it is not a formation or decomposition reaction, then we can't just look it up in the data book. If this was a formation reaction, we could look it up on page 4 or 5 and figure out the enthalpy for that. But in this case, it's a combustion reaction, combustion of hydrogen sulfide. So I cannot simply look up the value. I have to solve for it. For Hess's law method 2, to solve for delta H of a reaction, we can use the sum of all of the molar enthalpies of formation of each of the individual reactants and products. We have to multiply number of moles of each compound by the molar enthalpy of that compound. Okay, this we do first for the products. So we add up the sum of these guys and then subtract from it the sum of the reactants. So we take number of moles times molar enthalpy. Sorry, there should be an F because we're using always molar enthalpy of formation for each of the individual reactants. Guys, just remember it's alphabetical. P, R. It's always P minus R, not the other way around. So let's start subbing in some values here. If you look up on page 4 and 5 in your data book, the value for H2S, the molar enthalpy, so remember that's delta FHM, for H2S is negative 20.6 kilojoules per mole. O2 is not listed, it's an element, and all elements are zero. So it's 0 kilojoules per mole for oxygen. SO2 is negative 296.8 kilojoules per mole. And then the last one, water, there's two values for water because it's a gas. We use the value for water vapor, which is negative 241.8 kilojoules per mole. Now all we have to do is sub this all in. So start by taking the sum of all of the products. And I'm going to put these in a large set of square brackets so that I don't mix it up. We need to take moles times heat of formation, molar heat of formation. So SO2, there's 2 moles of it. And I'm going to multiply this by the molar enthalpy of formation, which is negative 296.8 kilojoules per 1 mole of SO2. Moles of SO2 cancel, leaving me with just kilojoules. So we're going to do that for all of them. So I'm going to add to that 2 moles of H2O and multiply it by negative 241.8 kilojoules per 1 mole of H2O. And I'm going to close that big set of brackets. So I want to simplify that, and then from it, we're going to subtract the sum of all the reactants. My first reactant, I've got 2 moles of H2S times molar heat of formation, which is negative 20.6 kilojoules per 1 mole of H2S. Moles of H2S cancel, moles of water cancel, and everything we're left with is in kilojoules. So when we simplify this, our final answer will be in kilojoules. If we simplify the first set of brackets, so 2 times negative 296 plus 2 times negative 241.8, I'm going to get negative 1077.2 kilojoules minus this last part here. I can just put a plus 0 for the oxygen because I know that the value is 0. So it's just going to be 2 times negative 20.6, which will give me negative 41.2 kilojoules. Minus a negative, be careful with that, and we're going to get negative 1036 kilojoules.